Hey guys, welcome to this video today. I'm going to be going over graphs of secant and cosecant. So we're going to look at cosecant and secant, and I'm going to refer back to when I did step-by-step graphing. And if you aren't in my class, this should make a little bit of sense. I'll try to do a little bit of both. It should make a little bit of sense for both of it. So what I'm going to do here, we're going to start with y equals cosecant. Oops. Y equals cosecant of x. And remember that cosecant is 1 over sine of x. So if I graph the sine function, so the sine graph, and for this so that we can see everything on here, I'm going to use this as a unit of 1 here. Oh, you can't really see that yellow, can you? So this is going to be 1 here. All right, this is negative 1. So for sine, we go up to here, down here, we got a curve that looks like this, comes down this way, through here. Does the same thing over here. All right. So there's sine of x. And what I'm interested in though is basically graphing the reciprocal of sine of x, 1 over sine of x. So if you recall back to when I do my phone's on. When we did step-by-step graphing, we're going to take the x-intercepts and we're going to make asymptotes there, vertical asymptotes. So now if you weren't in my class or weren't watching, or I didn't go over those videos step-by-step graphing with reciprocals, you can go back and take a look at that video. Or you can just see that at these, where these are 0, that would make the denominator 0, which would make this undefined for cosecant. Now this is all positive, so when we did this for step-by-step graphing, this is all positive, so I'm going to start at the same place, and I'm going to go towards the asymptotes. And then here, start at 1, go towards the asymptotes. Here towards the asymptotes. And that is your graph of cosecant. So I think what you need to remember is that cosecant starts with a vertical asymptote at x equals 0, and then the period for cosecant, I mean it's called a period, but it's kind of weird to call it a period. This one's 2 pi. Because we have a down parabola and an up parabola. However, the distance between any two vertical asymptotes is pi. So when we're changing the period, we have a different b in one of the examples. We're just going to look at the difference between the vertical asymptotes so that we can change them just like we changed the tangent and cotangent in the previous video. So let's take a look really quickly at secant. Remember that secant is 1 over cosine. So cosine starts here and goes down. So cosine goes like this. Do my best cosine here. All right, so just as we did the previous one, we're going to do secant. And secant means, so now we're at zeros here, so we're going to have our x, our vertical asymptotes. And I know my vertical asymptotes are perfectly straight. Then I'm going to go up here, and down there. So we're really looking at the green graph, and that would be your secant graph. Remember that secant is the reciprocal of cosine. Okay, so we're looking at these graphs. Same follows here. Is 2 pi over b is the period, but the length between each vertical asymptote is pi. So let's take a look at some examples of how we would graph things that change, maybe a phase shift or a period change to each of these. So let's sketch the graph of y equals 2 secant 2x. Sorry, it's on a different line here. 2 secant 2x. Okay, so what I normally say to do is you should always start with your parent graph, and the parent graph is going to be secant x. And so if you go back to if you want to rewind and go see that again, secant x is 1 over cosine, so we're going to have vertical asymptotes at pi over 2 and negative pi over 2, and then every pi distance after that. And secant looks like this. Okay. For the purposes of this one, these are 1 and negative 1. Okay. So this is our parent graph secant. But I don't want to take the parent graph secant. I want to change this to 2 secant 2x. Now, if this were cosine, if I had cosine of if I had 2 cosine x, it would change the amplitude, which would make it raise the max and the min. Well, that's what the 2 does in this case. It just basically changes the vertex of the parabola up to whatever this number is. So this is 2, so it's actually going to just shift it. Well, it's not really a shift. It's going up to 2 and down to negative 2. So what I mean what I mean by that is that whatever our graph is going to be, it's going to be up to 2 and then down to negative 2, and you'll see that in just a second. But what I want to do first is I want to change the period. So remember from the tangent and cotangent curve that the order to change the period, we took the vertical asymptotes, and we took those vertical asymptotes and we divided by b, and we're going to do the same thing here. So we're going to take the vertical asymptotes and divide by b, and in this case b is 2. So that's going to give us pi over 4. So that's going to be our first one. And I'm going to get rid of the secant graph here. I'm sorry, wrong one here. I'm going to get rid of the secant graph because it might just confuse us a little bit. But we know that it starts upward then downward. So we're going to go to pi over 4. It's going to be our new vertical asymptote. We'll do the same thing with the negative. We'll get negative pi over 4. Now instead of being at 1, we're going to be at 2. So we're going to start at 2 and we're going to go up. Now the distance between this is pi over 2 units because our period, again, well, our period, the distance between these are going to be pi divided by b, which is 2. So my next one's going to be here at 3 pi over 2. Then my next one's here. I'm sorry, that was 3 pi over 4. Okay, so now that I'm going up here, and I'm going to have to go down here. So here's 2, down this way. And then up. And then down. Up, down, up, down, up, down, up, down, up, down. Up, down, up, down. Up, down, up, down. Up, down, up, down, and so forth. Okay, and it keeps going. You don't have to draw all of them in there, but that's pretty good to give you a good idea of what the graph does. Let's take a look at a phase shift. All right, so this one is cosecant of x plus pi over 2. So we're going to go ahead and start with cosecant of x. There's no period change. This is just a phase shift to the left, pi over 2 units. So cosecant, remember from previously, cosecant starts at a vertical asymptote of 0 because this is, if you ever get stuck, just change this back to 1 over sine. And you know that sine crosses the x-axis at 0. It starts and goes like this. Starts at 0, that's where the vertical asymptote has to be. All right, so it goes up, then down here at pi, that'll be my next one. This is similar to cotangent. Okay, so there were my vertical asymptotes for my cosecant graph. Well, I got to shift it over pi over 2 units to the left. So I'm going to take this asymptote and I'm going to shift it over right there. I'm going to take this asymptote and I'm going to shift this one over right there. I'm going to take this one and shift it over right there, pi over 2 units. I'm going to take the next one, shift it over pi over 2 units. So let's draw that. Let's use blue here. Oh, let's use a different color. Let's use purple. So my new one. Now, here's an important thing to remember, depending on when you're shifting to the left or the right. You need to know if you're shifting to the left or the right, because originally my cosecant was going to be up this way. And I'm shifting that graph over to the left. So now I'm going to be up this way. Had I shifted to the right, then the curve on this side that shifts to the right would have been down here, and I would have started in the middle here with the down-facing parabola. Okay, so we're going to complete this just for a couple of them so we know exactly what it looks like. All right, it's going to keep going up. Same thing here. Goes the other way, up that way too. Okay. All right, so that's it. That's cosecant and secant. Remember, they go like this and like that. They're parabolas where tangent and cotangent, they went like a curve, like a cubic. So cotangent, tangent are like cubics, and then cosecant and secant are like parabolas up and down. I know I'm doing a lot of hand gestures, but maybe you'll remember them this way. Okay, like this, like this. And then it just depends on where you start with the asymptotes. But the same rules apply for all of these. Just take the asymptotes and either divide by b to get your new asymptote, or shift them over left or right depending on what your phase shift is. So I've got a couple of practice problems here. Went the wrong way here. I got a couple of practice problems for you to try if you want to try them out. Oh, I don't have that in the right place here. So here they are, and because I know some of you're looking on a little small screen, and so this asymptote right here, this is pi, so if you can't see it, it's pi, and then the next one is 2 pi, and the next one is 3 pi. I know the last one kind of came out, they're kind of small, but try these out. If you can, try them out. It'll make it much easier for you to do some problems at home. Or if you're coming to class, do some problems in class for a flipped classroom. But I think these will help you out. You can find the answers on the WISC link down below, and we'll see you next time. Thanks.